This is section 5.1, part 2. Let's look at the definition of a power function of degree n. It's a monomial function in the form f of x equals a times x to the n. Monomial, one term, where a is a real number, but not 0, and n is greater than 0 and is an integer. So previously we saw n could be 0 and we had that horizontal line, but now we're not talking about horizontal lines, not for a power function. N has to be greater than 0 and be an integer, not a fraction. Notice that we could also define a polynomial as a sum of power functions. So think about the polynomials. If we take monomials like this and plus a sub n minus 1, x to the n minus 1, it was a sum of several monomials. That's what they mean by that. Let's do this exploration and look at the graphs of the power functions. It says to use a graphing utility, but we'll just look at these and talk about them and then answer some questions below. So on these three curves, one of them is y equals x squared, one of them is y equals x fourth, and then one of them is y equals x to the sixth. So let's see if we can figure out which is which by plugging in known values and think about that. Notice these are all even numbers. So let's just take a minute and maybe above this side, let's write even, because we'll be comparing that to the other side where you'll note x cubed, x fifth, x seventh, odd. So we're going to look at the difference between these. You can already see visually there's a difference in their graphs, right? Okay. So what would we compare here? Obviously, you put in 0 for all three of these. X is 0, y is 0. That's why you see all three of them having a vertex at the origin. Okay, we put in 1 for each of those, and what happens? That also does the same thing. So we see that we have 1, 1 and negative 1, 1 for all three. They all three go through those same points. So what can we do to find where y equals x squared? Well, if we put in 2 here, we're going to get a different result for the other two. So 2 squared is 4. So when x is 2, we get 4. So we just discovered that this one is y equals x squared, because when we put in 2 here, we're going to get what? 2 to the 4th is what? 16, and we put in 2 here, 64, right? That's right, isn't it? I think that's right. Check me on that. Okay, so here we have y equals x to the 4th, and then we go y equals x to the 6th. Okay, let's talk about the even-powered functions. Do they share the same shape? Yeah, they're approximately the same. They're this U shape, right? Yes. Do they share any points? Yes, we noticed this one, I didn't point it out, but this one also, right? So yes, and let's list those points. They share, when x is negative 1, you raise negative 1 to 2nd power, 4th power, or 6th power, you still get positive 1. They shared 0, 0, of course, and 1, 1. Are they symmetric to the y-axis, the x-axis, or the origin? Well, let's think about what that means. By asking us that, they're just saying, is there like a folding line? If you folded it across the y-axis, would it fold completely, perfectly in half, or across the x-axis or the origin? So what do you think that is? Is it symmetric to any of those three? The origin would mean folding across both. So yeah, the y-axis. The y-axis is like a folding line for this. It's the axis of symmetry for that parabola, right? But it definitely would not be the x-axis or both, the origin. Okay, what's the domain of the even-powered function? Well, what's the domain of the quadratic function? It's all real numbers, right? And the range? Well, our lower limit is 0 and upper limit positive infinity. What happens to the graph as n, the exponent, increases, as our n's 2 goes to 4 goes to 6, and as x approaches positive infinity and negative infinity, and then we'll look at approaches 0 from here going in toward to 0. So what's going on there? Well, what's happening to it is as we go from x squared to x to the 4th to x to the 6th, as we're going out to positive infinity, what's happening to our graph? It's getting steeper, isn't it? Here it's kind of sloping, but as we go out further to positive infinity, we see our x to the 4th being steeper, and x to the 6th even steeper. So it is steeper as x goes to positive or negative infinity. And then what's happening coming in towards 0? As we approach 0 from both directions, we see our y equals x squared here, the solid line. The other two, notice they're kind of flattening out. The bottom of those bowls, if you will, are sort of flattened out. So we'll say flatter as x goes to 0. From either direction as x is going to 0, we see as our ends go up, we get a little bit flatter on the bottom. Okay, now let's label our cubic functions, and what we'll find is that we again share 0, 0, and positive 1, negative 1, negative 1. They all go through those points, and then things change after that, right? So what we find is that the solid one is our y equals x cubed. Then we have y equals x to the 5th, and then y equals x to the 7th. Okay, do they share the same shape? Sure, they've kind of got this snaky little S type shape, so yes. Do they share any points? Yes, we just pointed that out. Negative 1, negative 1. Oops. 0, 0. And positive 1, positive 1. Is it symmetric to the y-axis, x-axis, or the origin? So here we saw you could take this point and fold it directly across the y-axis. But here, that's not the case, right? Not across the y, not across the x, but actually across both. What do we mean by that? If I flip this one across the y-axis and then across the x-axis, notice that point goes here. So this one is actually symmetric with respect to both the x and y-axis, and when that's the case, we say it is then symmetric to the origin. What's the domain? Yep, all real numbers. How about the range? Yep, all real numbers. And what happens, again, let's think about it as n increases from 3 to 5 to 7, and we are going towards positive infinity. What's changing about our graph? Again, it's getting steeper, right? And as we go towards 0, what's happening? Again, we see the dotted ones tend to flatten out. So we actually have the same response as we had here, steeper as x goes to positive and negative infinity, flatter as x approaches 0. The graph of every polynomial function, recall we've said, is smooth and continuous. All right, we will continue in our next video.